All right, so in our previous segment, we talked about the Milky Way galaxy, which is just one type of galaxy. So now we want to talk about galaxies in general. And so, what are the typical parts of a galaxy? So, we've already mentioned that a galaxy is going to have a halo. So, all galaxies, whether they're spiral or elliptical or irregular, they're going to be surrounded by very, very old stars. So, whatever galaxy you got, that galaxy is going to be in the middle, and then it's surrounded by this halo, which represents the original material that formed the galaxy in the first place. Okay, now most galaxies are going to have a central part to them. So, in the center of most galaxies, that's where the stars are the most concentrated. And so that's going to be the central bulge. Okay, now only spiral galaxies are going to have disks, arms, and bars. Okay, so let's talk about what arms are. So a arm of a spiral galaxy is a density wave. So in the same way that if you take a rock and you throw it into a pond, it's going to cause ripples in the pond. And each of the ripples is going to represent areas where the water is concentrated. So similarly, as a galaxy forms, certain areas of the galaxy are going to be compressed, and then because of angular momentum, those compressions are going to rotate around with the galaxy. Those are going to be the arms. So the arms are going to be rotating at just one speed. Okay, so in the picture that I've got there, I'm showing a picture of a highway. Okay, and then I've got a truck that, let's say that this truck is going at 55 miles per hour. So that's going to be its speed. And that is going to represent this density wave, because behind it you have all of these other cars that are getting clogged up behind the truck. So these cars are getting concentrated behind this truck because of the speed of this truck. So this is going to represent the density wave that is going to be going around and around in a spiral galaxy. Now, the individual cars are going to be stars. So some stars are going to be going faster than the arms. Some stars are going to be going slower than the arms. Okay, now why is that true? Okay, because if we draw a picture of the galaxy is going to obey Kepler's laws of motion. And so if this was a solar system, do you remember that inner planets move faster than outer planets? So if this is the speed, so I'll put a big V for like the speed of Mercury as it goes around the sun, and then let's put a little v out here because that would represent, let's say, the speed of Jupiter. So Jupiter goes around the sun slower than what Mercury does. So according to Kepler's laws, the further out you get from an object that is exerting gravity, the slower you're going to go. So now let's pretend that this thing, instead of being a solar system, is a galaxy. So that you're going to have some stars that are orbiting the central bulge are going to be able to go around very, very fast. Then you have out here, you're going to have the stars that are going around the central bulge much slower. So if you recall, we said that, for example, the rotational speed of the Earth as it's going around the Milky Way galaxy is 490,000 miles per hour. Well, a star that is further out than our sun would be going slower than that speed. A star that is closer to the galactic bulge than our sun would be going faster than that speed. So all of these stars are going at different speeds around the galactic bulge. Also, if you recall, we talked about Saturn, and we talked about the rings of Saturn that were composed of pieces of ice that were about the size of your fist. And then every one of those pieces of ice were moving around Saturn at different speeds because they all were obeying Kepler's laws. Different distances, different speeds. Okay, so that means, going back to this picture down here, you got some cars that are going to be faster than the truck. So they're going to go and pull ahead of the truck. You got other cars that might be going slower than the truck, and so they're going to fall behind. They're going to get further and further behind. Now, let's imagine that this highway makes a circle. Okay, then it would be possible for one of these fast cars to get out ahead of the density wave and then circle around the galaxy and then come up behind that density wave and go through it a second time. Likewise, for these slow ones out here, what could happen is the density wave could be, since it's going faster, could go around and then catch up with these cars back here, and the density wave would go through these slow moving cars. So the same thing is going to happen with a rotating galaxy, that these arms, these density waves, as they're rotating around, they are going to be either being catch up with stars, or the stars are going to catch up with them, or if they're at just the right distance from the galactic bulge, then that star will spend its entire life inside of that arm, and then they both will rotate around at the same speed. Okay, so that explains what the density waves are. So let's go back to this picture here. Okay, and now the next question is, well, what then is a bar? Okay, so that in some spiral galaxies, so here's our spiral galaxy, there actually is a structure that goes through the center of the galaxy, and then the arms are coming off of that structure. So we refer to those things as being bars, B-A-R. So that's a bar. Arms can come off of that bar, and then the whole thing is rotating around. Now, we don't think that our galaxy has a bar, but it could. Because, for example, if our sun was located right here, then if we were to look at the center of our galaxy, we would be looking through the bar and we wouldn't notice anything. So maybe our galaxy has a bar, it's just that we don't notice it. Now, if, on the other hand, if the Earth was over here and we were looking in this direction, it would be easy to see if our galaxy has a bar. But as far as we know, our galaxy does not have a bar. What causes the bars? That is area of ongoing research. So I'm going to show you here in a few moments a video that shows two galaxies colliding. And if you look closely at that video, you might see a structure that kind of looks like a bar. So it might have something to do with the density of the galaxy. It might also have something to do with the rotation of the galaxy. It might have something to do with the collisions of galaxies that form these bars. So I'm more interested in what causes the arms. And again, we think that the arms get started as a result of collisions between galaxies. So these density waves, that's how they get started in the first place. Okay, another thing that a galaxy is going to have, if it is rotating, is going to be a magnetic field. So most objects in our universe are rotating. Depending on the speed of the rotation, that's going to determine the strength of the magnetic field. So our Earth is rotating, it has a magnetic field. Our sun is rotating and it has a magnetic field. So similarly, our galaxy is rotating, so our galaxy is going to have a magnetic field. So it's going to have a magnetic jet that is going out the top and the bottom of the galaxy. Okay, another thing that a galaxy can have is a dark halo. So we said that this thing here that is surrounding the galaxy is the halo, which consists of very old stars that originally formed the galaxy. Okay, now what the dark halo is it's up to 10 times larger. It's dark. That means you can't see it. So imagine this picture here and then expanding it by a factor of 10. And then all of this material out here is going to be dark matter. So that's why we call it the dark halo, is because this material out here is going to be composed of dark matter. Now we haven't discussed dark matter yet, so we'll get to it, but just to give you an idea, dark matter cannot be seen. So it doesn't interact with visible or X-ray or gamma ray light. It doesn't interact with any kind of electromagnetic radiation. However, it does interact with gravity. So dark matter evidently has mass, and it causes gravity, and it reacts to gravity. But you can't see it because it doesn't react to electromagnetic radiation. So if you try to look for it using a telescope, you're not going to see anything. But you are going to be able to see the effects of dark matter by the gravitational interactions that it produces. So we'll talk about that later. Okay, let's take a break, and when we come back, we're going to talk about how do galaxies form.